And so let's work the problem as an example. It says how many moles of potassium sulfate can be produced from the reaction of 38.9 grams of potassium nitrate with excess calcium sulfate. So our reactants here are going to be potassium nitrate and calcium sulfate, and then we are going to use those to find out how much potassium sulfate can be made. So we'll start off with a balanced equation. Alright, so the first step would be to write down what we're given, which is 38.9 grams of potassium nitrate. And we are given grams, and we're asked to solve for moles of another chemical, the potassium sulfate. So we're asked to solve for moles of this guy, and we're given grams of this guy, which is 38.9 grams of that guy. So those are the two chemicals that will be involved, and we have two steps because we've got to go from grams of one chemical to moles of the same, and then from moles of one chemical to moles of another chemical. So we'll need two conversion factors here, moles to moles there. Alright, so let's get started on it. Whatever you have in terms of a unit in a chemical will always go on the bottom of our conversion factor so that it will cancel out. So we got grams of potassium nitrate here, and we're going to go to moles of potassium nitrate. Whenever you go from grams to moles, it's always 1 mole. And then let's label this good, KNO3. So we'll have moles of KNO3 on the bottom, potassium nitrate, and then moles of what we're solving for on top, which is moles of potassium sulfate. So now we just got to fill in the values and solve. So the first one will need the molar mass, because when you go from grams to moles, you need the molar mass. So let's do a molar mass of potassium nitrate. We have 1 mole of potassium in the compound, 1 mole of nitrogen, and 3 moles of oxygen. Potassium's 39.1 grams per mole, oxygen's 14 grams per mole, and oxygen is 16 grams per mole. So here we have 39.1, 14.0. 3 times 16 is 48. Double checking myself here. 48. You add all those up, you get 101.1. Okay, so there is our molar mass of our potassium nitrate. And so now we're going to go over the mole bridge, moles to moles. So we need the balanced equation to do that. So moles of potassium nitrate, we have 2 moles of potassium nitrate for every 1 mole of potassium sulfate. Remember, there's nothing there, it's assumed to be 1. Alright, so now we multiply across the top and divide by the bottom. So it's 38.9 times 1 divided by 101.1 times 2. So when you're plugging this into your calculator, be sure to keep the order of operations straight, or you might get the wrong answer. And when I do that, I get 0.192 moles. Okay, very good. So we have another problem coming up here, another mass to moles type of problem. So what I would like for you to do, we'll use the same balanced equation. I'd like for you to go ahead and work this one, and then we'll work it together. So pause the video here, work the problem, and then we'll work it together. Alright, hopefully you did that. So we're starting off with 106.7 grams of calcium nitrate. So we are desiring a grams of our product, and we're asked how many grams of the reactant, how many moles of the reactant that we need. So we're going to go from grams to moles, and moles back to grams this time. So a very similar problem, just a little bit different approach. So we'll still start with grams on the bottom of whatever that we're given, just like before, calcium nitrate. And we still need to change that to a molar amount so we can change chemical species. And then we are going to go to moles of the reactant. So for every 1 mole of calcium nitrate, or mole of that product, we'll need, I said 1 mole because it is here, calcium nitrate is a 1. Be sure to emphasize that one. And then we're going to go to moles of calcium sulfate. And in this case, it's going to be 1 mole of that one as well, because there's no coefficient in front of the chemical in the balanced equation. Okay, so now we just got to figure out our moles of our calcium nitrate. So let's do that. So let's do that in red. Why don't we? So we got 1 mole of calcium, it's 40.1 grams per mole. And then we've got 2 moles of nitrogen, which are 14 grams per mole, which will give us 28. And then we've got 2 times 3. 2 times 3 is 6 moles of oxygen. 6 times 16. And 6 times 16 is 96. And when we add all those up, we get 164.1 grams. And that will go on the bottom. Alrighty. So now we just multiply across the top 106.7 times 1 times 1, divided by 164.1 times 1. And if you do that, you get 0. We'll do this in black because that's the reactant. 0.6502 moles of calcium sulfate. Okay, very good.